Okay, welcome back. Now, in the previous video, we just finished creating this widget blueprint, and we added the pickup widget variable to our item class. And so our weapon inherited that. And so we went into our base weapon BP, and we took our pickup widget, and in the details panel, we selected our pickup widget BP, and we set the draw size to 400 by 125 or something like that, and set the space to screen space. And now when we press play, we can see the widget, and it's showing up exactly in the location of the weapon. Now, we want this widget to be slightly above the weapon. So let's go ahead and select the pickup widget here in the blueprint, and let's raise it up by about 70 or so units. So now its Z location will be 70. So now when we hit play, we'll see that the widget shows up just above the weapon. So in this video, what we'd like to do is we only want to display this widget if we are looking at the weapon itself. So let's go ahead and get started. So the first thing we want to do is make this widget invisible from the beginning of the game, so its default state is hidden. So back in the C++ class, let's go to item.cpp, and we'll see that we have this pickup widget, and we want to make the pickup widget invisible. So we can do this in begin play. So let's make a comment here and say hide pickup widget, and we're going to use pickup widget, and we're going to call set visibility, and we'll pass in false. And so this will make the widget hidden by default. So if we compile this and we head back in the editor and press play, we'll see that it no longer shows up on the screen. Now it is there, it's just set to hidden, so we can't see it. So what we'd like to do is we'd like to show the widget when we hover our crosshairs over the gun. So when we're looking at the item, the widget pops up, but when we look away, the widget goes away. So the first step is getting that widget to show back up, setting that visibility back to true. So let's get started with that first step. So back here in Visual Studio, we're going to create a function in shooterCharacter.h for tracing under the crosshairs. Now we do trace under the crosshairs when we're shooting the weapon, so we're going to do something similar to that. So why don't we go back into shooterCharacter.cpp and take a look at our function getBeamEndLocation. GetBeamEndLocation is essentially a function that contains a line trace from the crosshair location. This is similar to what we're going to do when we trace to look for items so that we can show their widgets. So let's go ahead and create a new function in shooterCharacter.h. Let's go up to the protected section where we have our protected functions, and let's create a new function. And I'd like this function to return a Boolean to report the success or failure of the line trace. And I'm going to call this function trace under crosshairs, and it's going to take an fHit result. And I'm going to call this out hit result. And so what this will do is perform a line trace under the crosshairs to see what it is that we're looking at and return a Boolean reporting whether or not that trace actually hit something. And our out hit result will contain the information regarding the trace hit. So the comment will say line trace for items under the crosshairs. And I'll go ahead and let Visual Studio give me a body for this function. And so in this function, we're going to set this up to perform a line trace. So in order to perform a line trace from our crosshairs location, we first need to get the location in the screen of our crosshairs. So we need our viewport size. So we're going to say get viewport size, And we got the viewport size in the get beam end location function. So we can go ahead and get that. So let's search for beam end location. And here's our get beam end location function. And here we get the current size of the viewport by getting an f vector 2d local variable, checking the engine and the viewport, and then calling gengine game viewport get viewport size. So we're just going to go ahead and copy that, and we'll put that in our new function, trace under crosshairs. So we'll go back to trace under crosshairs, and we'll paste that. So we're going to get the viewport size. Next, we need to get the actual location of the crosshairs, which is the center of the viewport, which we also do in get beam end location. We say get screen space location of crosshairs, which we do by creating a f vector 2d and initializing its x with viewport size x divided by 2, and its y with viewport size y divided by 2. That's basically how we get our crosshairs location. It's the center of the screen. And from there, we call dproject screen to world, passing in two f vectors, a crosshair world position and a crosshair world direction. So we can copy these lines, and we can put this in our new function as well. So let's go back to trace under crosshairs, and we'll paste in this functionality. So dproject screen to world returns a Boolean called b screen to world, and we can check this to make sure the dproject screen to world was successful. So let's check if b screen to world. Then we're going to trace from crosshair world location outward. So remember, we created these f vectors, crosshair world position and direction. We passed them into dproject screen to world, and dproject screen to world filled them in with the location and direction vectors for our crosshairs in the world space. So we can now do a line trace starting off at the crosshairs world location. So let's do an f vector, and let's call it start, and we'll initialize this with the crosshair world position. And since we don't plan on changing this vector, we're going to make it const. Now we can make another const f vector. We'll call this end. This will be the line trace end location. And just like we did when tracing for our weapon fire, we're going to set this equal to start plus crosshair world direction times the length of the line trace, which for the weapon fire, we used 50,000. .f. So we got the start and end location, and we can finally call get world line trace single by channel. Now line trace single by channel takes a hit result, and this function we're making called trace under crosshairs takes an f hit result by reference called out hit result. So we're going to pass that in to line trace single by channel. Next we need our start vector, which we called start. Then we use our end vector, which we called end. And finally, we want our collision channel, and just like our other trace, we're going to use the visibility channel. So E collision channel, ECC visibility. So finally, trace under crosshairs returns a Boolean, and we can return true if this hit result has a blocking hit. So all we need to do now is just check if out hit result dot be blocking hit, then we can return true. Now if there is no blocking hit, this if check will fail and we'll never reach this. So by the time the function finally returns, it will return false. But if we do get a blocking hit, then we will go into this if check and we will hit the return statement, which will terminate the function early, returning true. An out hit result will be populated with the information from the line trace. So this function gives us a nice way to trace under the crosshairs and get a hit result that contains information about that line trace. So we're going to use this trace under crosshairs function. And for now, I'm just going to use it in the tick function. Let's go to tick. And here in tick, we're just going to call trace under crosshairs. And of course, we're going to need an f-hit result. And we'll call this item trace result. And we'll pass in item trace result. And if this has a blocking hit, then we can simply see the actor that we hit. Now, I'd like to cast that actor to an A item. So I'd like to say A item, hit item, equals, and I'd like to cast to A item that item trace result dot actor. So essentially, if we get a blocking hit, we're going to see the actor that we hit and cast it to an A item, which means we need to include the item.h header. So let's go up to the top and include that. Include item.h, and we'll come back down. And once we've cast it, we need to see if that cast was successful. If hit item, then I'd like to get the hit item and set that widget visibility to true. So we're going to say show items pickup widget. Now, in order to set the visibility on the widget to true, we need to access the items pickup widget. But remember, on item.h, our pickup widget is a private variable. So we need a public getter for this. So let's go ahead and add that to item.h. Let's make it a force inline function that returns a uWidget component pointer, and we'll call this get pickup widget. We don't want this function to change the state of item. We just want it to return a value, so we're going to make it const. It's simply going to return pickup widget. So that's it. We have a getter. So back in shooter character, we're going to set the visibility to true. But before we reach in and get pickup widget, why don't we check the value returned by get pickup widget to make sure it's not null? And we can do that here while we're checking for hit item. We might as well go ahead and check hit item get pickup widget. So the if check will first check hit item, and if that's valid, then we'll check hit item get pickup widget. And if that's valid, now we can access it. So we'll access it by using hit item get pickup widget, and from there we'll go ahead and set pickup widget's visibility to true using set visibility, passing in true. Now we get this pointer to incomplete class type is not allowed because we are returning a pickup widget, which means we need to include the header for the widget component. Now we use that in item.cpp, so we can go up to the top of item.cpp and get the header from there. Include components/widget component.h, and we can include that in shooter character up here at the top. So now this shouldn't have any errors in it. So here in the tick function, we're simply going to call trace under crosshairs every single frame, which I know that's not very efficient, so we're going to have to optimize this. But for now, as we're developing, we just want a proof of concept. We want to see if we can get this widget to show up just by looking at it. So we're going to perform the line trace every frame. Now, before we test this out, the last thing we need to do is make sure that the item collision box is set up to be hit by our line trace. So let's go to item.cpp, and here we have the construction of our collision box. Let's go ahead and set up the collision so the collision box is behaving correctly. First, I want its collision response to be ignore for all channels. So collision box, we're going to call set collision response to all channels. This takes a collision response, which is an E collision response. That's an enum, and we're going to use ignore. So essentially the collision box will ignore all collision channels, and this way we can just simply set it to block the one that we're interested in, which is visibility, and all the rest will be set to ignore. So let's call collision box, and this function we're using is set collision response to channel, and this sets it to a single channel. So it takes an E collision channel, and we're going to use visibility, and then next it takes a E collision response, and we're going to have it block the visibility channel. That way it will actually block when we're trying to do a line trace. So now that the collision box is configured to actually block the visibility channel, let's see if our line trace works. We'll go ahead and compile this.
Now, something that might trip up some students is after you've changed properties in C++, if you're not seeing that change reflected in the game, you might want to come into the blueprint and select the component that you've changed in C++ and make sure that those properties are updated here.
Okay, so we're back in the editor. I'm going to press play, and I'm going to move up to the weapon, and I'm going to hover just over the weapon, and there we go. We display the widget because we are calling set visibility passing in true. Now, it doesn't hide again because we never actually set the visibility to false again. We only set it to false in begin play. So that's another thing to keep in mind. So we're going to need to take care of that in a future video. And also we are line tracing every single frame, which is not very efficient. So we also need to make sure that we only line trace when appropriate. So this will conclude this video. In the next video, we will continue scripting out the functionality for the pickup widget. We'll see you soon.